This is the video called 2.1 Part 2, and you are asked to label the sides of these triangles. In this triangle, you are standing in this corner right here. First thing, go to the right angle, go immediately across from that. That is your hypotenuse, which we're going to shorten to hype. Next, go back to your corner and draw a line straight across. That side is called the opposite. And the third thing to do is look at the side that is immediately beside where you are standing, and that's going to be called the adjacent. In this triangle, you are standing down here. Now this time we have a theta symbol in the corner to tell you where you're standing. Again, go back to the right angle, go across from it. That's the hypotenuse. Across from where you are standing is called the opposite, and this side is called the adjacent. What we have here is section 2.1, part number 1, and we're going to be studying right-angled triangles in this chapter, and specifically in this unit we're going to be studying the tangent ratio. So the first thing we need to talk about is how we label triangles. If you can't label them correctly, it'll be difficult to get the right answer. So the first thing you need to do is know that capital letters are used to label angles, and small letters are used to label sides. The first thing you need to be able to identify is the angle. Now you'll notice that in this right angle triangle there are three angles. There's the right angle, which is right here. There's angle A, which is here, and angle B, which is here. Even though every right angle triangle will have a right angle, we never use that as the point of reference. We always use angle A or angle B to start from. And you decide where you're going to stand, and where your angle is that you're standing at is usually identified by a little marking down there. So in this case, angle A is the reference angle. Sometimes you're going to notice in this course we have this symbol here that's used to talk about the size of an angle, and it's called a theta. We have three sides in the triangle that we need to name. One of them is called the hypotenuse, one of them is called the opposite, and one of them is called the adjacent. So if you are standing in this particular triangle and you are standing right here in this corner, the first thing to notice is that if you draw a line directly across the right angle, that tells you the hypotenuse. Go back to where you're standing. The side across from you is called the opposite, and the side beside you is called the adjacent. If you label the hypotenuse first, you won't make any mistakes in the other two sides, hopefully. And so the first thing I'll get you to do is to label the sides in the following triangles. This is 2.1 part 3, and at the top of your page you have a little bit of a history about how we're going to develop this formula. And the main point of today's section is to develop this formula that's called the tangent of angle A. And the tangent of angle A is a fraction that's found by taking the length of the opposite side and dividing it by the length of the adjacent side. You'll notice that we've taken this formula and we've shortened it so it looks like this. And quite often we'll shorten it even further just by writing op over adj. What I'd like you to do next is just to read this over and ensure that your calculator is working properly. And once you've done that, we'll be able to go on to do these following examples. First thing you're asked to do is says find the tangent ratio for the following triangles. And what you need to know is that the word ratio is a fancy word really just for a fraction. So our answer is going to be a fraction. First thing we're going to do is write down the formula. The tan of A is equal to op or opposite over adjacent. Now let's go to our triangle here. We are standing in this corner here. Let's label everything we know. First thing to do is to label the hypotenuse. Go back to where you're standing. Go across from that. Label the opposite. Go back to where you are. And the side beside where you are is called the adjacent. And let's fill in what we know. Is our angle called A? Yes, it is. So we're going to leave it as A. How long is our opposite side? It's 11. And our adjacent side is 8. You will notice that sometimes we actually take the 11 over 8 and we divide it in our calculator. And 11 divided by 8 is 1.375. This question here, same thing. Our formula is tan of A equals op over edge. Now let's take a look. We're standing up here this time. Go back to our little right triangle, or right angle. And this is the hypotenuse. Back to where we're standing. All the way down here. This now is going to be our opposite. This is a 4. And back to where we're standing. The side right beside where we are is the adjacent side. Let's fill in our formula. This time our angle is not called A, it's called G. So we're going to replace the A with a G. And the opposite side is 4. And the adjacent side is 22. If we were to change that to a decimal, we would get 0.1818. Usually the answer we want is a fraction one, but it's okay to change it into a decimal. 2.1 Part 4. 2 things to review from last year. All 3 angles in a triangle add up to 180. That means if you have any triangle in the world, right-angled or not, all 3 angles here, here, and here will add to 180. In our situation for this chapter, this angle will always be 90. So this 90 plus this will always equal 180 degrees. The other thing to review is the Pythagorean theorem. And it's a little small in my writing here. But if this is side A and this is side B, and the hypotenuse is always called side C, the Pythagorean theorem says that A squared plus B squared equals C squared. All right, again, let's make sure our calculator is working properly. We are going to first of all look at this question here. You're told the tan of angle A is equal to 0.5418. This decimal used to come from some fraction, just like in our previous example. I want to know how big the angle of the triangle A would be. So here's the buttons you're going to press in your calculator. You're either going to hit Shift along with tan, or tan and then Shift. You're going to decide which way your calculator works. If you follow the steps here, you should get the answer 28.44883476 should go up on our calculator. Now our question asks us to round to the nearest degree. That means that we are only going to have our answer to the nearest degree with no decimals afterwards. In order to do that correctly, we need to look at the numbers after the decimal place. If the first number after the decimal place is 5 or bigger, we are going to round this up. We'll notice that the guy I underlined is only a 4. He's not 5 or bigger, so I do not need to change this 8. My answer is going to be 28 degrees. 2.1 Part 5. In this question, we're asked to determine the measures of angle R and S to the nearest tenth of a degree, and we have some steps over here to help us do that. Step 1. Decide which angle to use as your starting point. Generally, the one down here is going to give us the easiest way of doing this question, so I'm going to call him our starting point. From there, we're going to do our labeling. So again, this is our hypotenuse. This is our opposite. And the one right beside us is known as our adjacent. Let's write down our general formula. The tan of angle A is equal to the opposite over the adjacent. Let's change everything to what we know. It's not called A this time, it's called R. So the tan of R is equal to 18 over 11. And this time we actually do want to make sure we change that to a decimal. So the tan of angle R is equal to 1.6364. In your calculator, you're going to type in 1.6364 second tan, or you're going to hit second tan first and then 1.6364, depending on what you found in your previous section. What you're going to find for angle R to the nearest tenth of a degree, which is 1 decimal, is 58.6 degrees. So now what I know is I have a triangle where this is 90 and this is 58.6. I now need to find out how big side S is, or angle S is. And what I do know is that all 3 of these angles will add to 180. So in order to find angle S, I'm going to take my 180 and I'm going to subtract from that 58.6 and I'm going to subtract the 90 in the corner. Angle S is going to come out to be 31.4 degrees. 2.1 Part 6. An acute angle is an angle whose size is between 0 and 90. An angle of inclination, which is also known as an angle of elevation, is an angle measured between a horizontal line, which is a line going this way, and a line pointing upwards. The angle in between those things, the theta or the A, is known as an angle of elevation, which is going to help us do the following question. And again, you'll notice there's some steps on the side to help you. So we have the teacher standing in the teacher parking lot in front of her vehicle. And all you see is the back of the vehicle. And yeah, 2 tires, very nice. There's Miss C standing in front of her vehicle, and she is 32 meters away from the building. And there's the building, and we have some windows. And she looks up, and instead of seeing her students working, they are looking out the window, waving at her. And she's very annoyed by that. So she looks up and she sees the students. And we're going to assume this building is 16 meters high, or the windows are 16 meters high. So here we have it. This is a right angle because Balfour is old but not too leany. And this is the angle we're looking for, and let's call it C for Carrigan. Let's use our formula. Tan of A is equal to opposite over adjacent. And let's label it. Here's our angle. Here's our hypotenuse. Here's our opposite. And here's our adjacent. What I know then is that the tan of A, actually not going to be called A, it's going to be called C, is equal to 16 over 32. The tan of C is going to equal 0.5. And using the second or the shift button on my calculator, I'm going to find out that angle C in this question is 26.57 degrees. We were asked to round to the nearest hundredth, which means 2 decimals. And in this question here, we have our 2 decimal places. Keep in mind that it's really important in the end that you don't actually have the word tan in your final answer. Once you hit the tan button in your calculator, you no longer use that word for your answer.